Hello guys, welcome back to VC Tech. In today's video, we are going to be talking about two major services that makes the internet and computer network work smoothly. Those include a DHCP and a DNS. Without these two, connecting to the internet or even another computer in your local network would be a real nightmare. However, by the end of this video, you will clearly understand what DHCP and DNS means, how they work, and why they are imperative in networking, and how they can make our devices communicate easily. So for this video, we will be using Cisco Packet Tracer to configure DHCP server and also a DNS server, and also assign IP address to all this device from the DHCP server. With that being said, let's look into a PowerPoint presentation I have, so we can have a bit of a knowledge about DHCP and DNS and why they are the backbone of IP communication. So understanding the roles of DHCP and DNS in modern networking. What is DHCP? DHCP stands for Dynamic Host Configuration Protocol. It is a network protocol used to automatically assign IP address to devices when they connect to the network. Think of a DHCP as a network assistant that gives every device an address when it joins the network, or just like how a hotel receptionist assigns you with a room number when you check in. That is how a DHCP works. Without a DHCP, every device, every laptop, every phone, every printer, and what have you would have to be configured manually with an IP address, subnet mask, a gateway, and a DNS server. And that would be time consuming and error prone, especially in a large network where we have over 100 or 1,000 devices to connect, and we have to configure that without a DHCP. That's going to be real time consuming. Now, why DHCP matters is its automation, as its efficiency, flexibility, and a centralized management. It automatically assigns IP address to devices on the network and reducing human error. As well as the efficiency, devices can connect instantly without manual setup, and when a device leaves the network, its IP address can be reused. As well as it has a centralized management, giving the network admin control over everything from one DHCP. Imagine a school with 300 computers. Configuring each one manually would take a very long time. However, a DHCP could do that in seconds. Now let's talk about what DNS is. A DNS stands for a domain name system. It's like the phone book of the internet. Why we use domain names like google.com or youtube.com, computer uses IP address to identify each other. The job of the DNS is to translate domain name into IP addresses, so users don't have to remember long numbers. Now, imagine us not having a DNS. This is why a DNS actually matters. So without a DNS, you would have to type IP addresses every time you want to visit a website. Let's say, for example, you want to go to google.com, you would have to type the IP address of google.com. Whatever IP address google.com use, that's the IP address you would have to type. And imagine if you have over 10 or 20 websites that you visit in a day, you would have to have an IP address of every website you visit. However, DNS makes the internet user-friendly by saving time with automatic name resolution. It also improves accessibility with easy to remember names, and it also enables scalability by handling thousands of domains efficiently. So how a DHCP and a DNS server works together is when a device gets its IP address from the DHCP server, it also receives the DNS server IP address from the same DHCP server. The DHCP server not only gives your device an IP, but it also tells it where to look when translating domain names to IP address, because the DHCP server is there. So what the DHCP server sets you up with is your IP address, as we have here, and your default gateway, also the subnet mask and the DNS server. So that's how both protocol works hand in hand to make your communication seamless. In conclusion for this, I would say DHCP automatically assigns IP address to network settings. DNS translates website names into IP address, and together they make the internet work simple and user-friendly. So with that being said, let's head over to Cisco Packet Tracer and see how we can configure DHCP and also a DNS to assign IP address. So we will be having our practical phase on how to configure DHCP and DNS server. On this phase, we will be using Cisco Packet Tracer, and let's assign this device with an IP address. Let's manually assign IP address to this device 192.168.1. Let's start from 10, and we want to give this default gateway 192.168.1.1, and the DNS server will be taking 192.168.1.2. So imagine if we have to do this configuration for every device in the network. We have 7 laptops. We have to do this configuration for 7 PCs. I mean, for 7 PCs, it might not be a lot, but imagine if you have to do that for over 1,000 laptops. It's going to be really time consuming. However, DHCP makes that easy for us. Okay, we already have this, so 192.168.1.2. DNS server takes 1.2. Now we've assigned IP address to the DHCP server manually. Let's go and configure DHCP to assign IP address to the host PCs. And as you can see, it's off, so you have to put it on. And the IP address starts from 192.168.1, and we want this IP address to start from 20. We also want to 20, and we also want the maximum to be just 50. And what we want to do is save. Now we've saved this, let's also go and configure the DNS server. We do that by assigning IP address 192.168.1.2. Just copy that. This for the DNS server. So we've assigned IP address to the DNS server, and let's also try to check this if IP address here is correct. The DHCP server is using .3. Alright, so previously we gave this device an IP address that says .10. Now let's try to get the IP address from the DHCP. And as you can see, we told the DHCP that we want to be getting our IP address from .20. However, our default gateway was not set. Let's go and see why it was not set. There it is. Oh, the default gateway was not set, so let's update that, and it's 192.168.1.1, and the DNS server, we want the DNS server to be 192.168.1.2. So by doing this, we've updated the system. Let's also check. Now we have our DNS server to be 168.168.1.2. 1.2, and our default gateway is also active. And if we try to assign IP address to every device on the network, as you can see, it's going to be going through, as this device has 21, this one will take 22, and so on and so forth. That is how a DHCP server works. Thank you for watching this video. If it helped you understand the backbone of IP communication, don't forget to like and subscribe and share with your friends. See you guys in the next video.